Hello students, today we are going to dive into what is the most crucial yet most misunderstood phase of the software development lifecycle, which is software maintenance. Most people and even some young developers believe that software engineering ends the moment the system is delivered to the client. They think the project is finished once the project is shipped. But in reality, that's just the beginning. The majority of the effort, time, and cost of the system occurs after it has been deployed. Think of a software not as a finished product, but as a living system. It must constantly evolve to remain useful, secure, and relevant in a world that is always changing. So let's start with a clear definition. Software maintenance is the modification of a software product after delivery in order to correct faults, improve performance, adapt to a new environment, and also enhance its functionality. Let's use a relatable example, your smartphone. Every few weeks, you see updates for apps like WhatsApp, Instagram, or Zoom. You download them, often without a second thought. But what are those updates actually doing? They are a perfect example of software maintenance in action. Some updates fix bugs you might not have even noticed, like a glitch in a camera filter that's about correcting faults. Others might make the app faster or use less battery. That's about improving performance. A major update might be needed to make the app compatible with latest version of iOS or Android. That's about adapting to a new environment. And of course, there are the updates that add brand new features like a new messaging function or a video call capability. That's about enhancing functionality. All of these activities combined are what we call software maintenance. It's the ongoing, essential work that keeps software alive and useful. I hope you understand. I have already teach about this a lot in our previous classes. I hope you understand this concept about software maintenance. We'll move on to the next slide. So what do you think? Why maintenance is so important? Think about it. Now, let's explore why software maintenance isn't just a core. It's a critical strategic activity for any business. There are 3 key reasons why is it so important. Long-term functionality. Software doesn't exist in a vacuum. The world around it is constantly changing. Business rules, security threats, and technological standards are always evolving. Without maintenance, software becomes obsolete. For example, consider a banking application. New government regulations are constantly being introduced to combat fraud or protect consumer data. A bank's software must be updated frequently to comply with these new rules. If it fails to do so, it could face huge fines and lose its license to operate. Maintenance is what keeps software relevant and functional over the long run. The next one is significant economic impact. Many people assume development is the most expensive part of the software project, but that's a common misconception. The reality is that maintenance typically consumes 60% to 80% of the total software budget. In many cases, the cost of the maintenance of a system over its lifespan is far greater than the cost of its initial development. This is why we talk about building maintainable software from the start. A system with a clean, well-documented code base is much cheaper to maintain than a messy one. Investing in quality from the beginning can save a company millions of dollars in future maintenance cost. The next one is the customer satisfaction. In today's competitive market, customer satisfaction is everything. A reliable and up-to-date application is a key factor in keeping customers happy and engaged. Thinking about a service like Netflix, the company releases small updates almost every week. These updates might fix a minor streaming bug but improve the video compression or add a small new feature. Their consistent small improvements enhance the user experience and show the customer that the company is actively invested in making their product better. This builds trust and loyalty, which are essential for long term success. So, maintenance isn't just about fixing bugs, it's about ensuring the software remains functional, financially viable, and loved by its users. We'll move on to the next slide. We know why maintenance is so important. Let's explore its unique characteristics. These are the things that set software maintenance apart from initial software development. The first characteristics is continuous and long term. Unlike a project with clear and end date, software maintenance is continuous activity that can span decades. Software has an incredibly long operational life. For example, some banking systems built on the COBOL programming language in the 1970s are still being maintained today. This means a developer in 2025 could be tasked with understanding and modifying the code that is over 50 years old. Next one is cost intensive. As we touched upon earlier, maintenance is expensive. Studies consistently shows that maintenance can account for 60% to 80% of the total software cost. The reason for this high cost is a combination of factors. They are the complexity of the changes and the need for frequent updates and the requirement for highly skilled, experienced developers who can understand and navigate large complex code bases. The next characteristics is high complexity of change. This is perhaps the most challenging aspect. In the new development, you are building a system for a blank slate. In maintenance, you are tasked with changing an existing system without breaking it. This requires a deep understanding of the entire system's architecture and the intricate relationship between its thousands of modules. For example, a seemingly simple update to a flight booking system might require analyzing thousands of interdependent modules to ensure the change doesn't accidentally cause a bug in ticket pricing or a baggage handling. I hope you understand. The next characteristics is dependency on legacy code. Maintenance often involves working with legacy code, a code that was written years ago using outdated programming practices with a little to no documentation. A maintenance developer often has to become a detective using a process called reverse engineering to figure out how the code works before they can even begin to make a change. The types of maintenance activities. To maintenance this complexity, we categorize maintenance into 4 distinct types. It's not all just about fixing bugs. First one is corrective maintenance. Second one is adaptive maintenance. And third one is perfective maintenance. And finally, preventive maintenance. We will look deeper. First one is corrective maintenance. This is what most people think of as maintenance. It's about fixing defects that are discovered after software has been released. An example would be patching a critical security flaw or fixing a login bug in a banking app. It's a reactive process. The second one is adaptive maintenance. This involves modifying the software to adapt to changes in its environment. This isn't about fixing a bug. It's about making the system compatible with a new operating system, a new database, or a new hardware platform. A perfect example is migrating an application from on-premises server to a cloud-based one. Third one is perfective maintenance. This is about improving the software's performance or functionality. It involves adding new features or making the system more efficient, often based on user feedback. For instance, adding a new dark mode to a mobile app or optimizing a database query to make a report run faster. Finally, preventive maintenance. This is a proactive activity. It involves restructuring or refactoring the code to improve its quality, readability, or maintainability, even if the code works perfectly fine today. A developer might refactor a module to remove deprecated code or make it easier to add a new feature into the future, thereby preventing future problems. Understanding these different types of maintenance is crucial because they each require different skills, resources, and planning. It's a complex, multifaceted activity that is essential for the long-term health of any software system. We'll move on to the next slide. The next slide is all about software reverse engineering. One of the biggest challenges in software maintenance is working with existing software you didn't create. This is especially true for legacy systems that lack proper documentation. This is where software reverse engineering plays a vital role. Let's define it simply. Reverse engineering is the process of analyzing a software system to identify its components, understand their relationships, and create a higher level representation or blueprint of the system. Think of it like taking apart a complex machine like a watch to understand how all the gears and springs work together. You are not trying to build a new watch. You are trying to understand the one in front of you. The primary purposes of reverse engineering are to recover lost documentation, to understand purely written or legacy systems, to migrate to new platforms, to detect vulnerabilities. I will explain this four purposes in detail. First one, to recover lost documentation. Many older systems were built without proper documentation, or the document has been lost over time. Reverse engineering allows us to recreate those critical documents. Next one is to understand purely written or legacy systems. It helps developers understand complex or purely designed systems before they attempt to modify them. Next one is to migrate to new platforms. When a company wants to move a system to a new operating system or a new programming language, reverse engineering provides the necessary architectural details to plan the migration. Next, to detect vulnerabilities. Security analysts use reverse engineering to decompile software and look for malicious code or security flaws. Here are some real-world examples. Legacy systems. A government department might have a 25-year-old tax system that is mission critical but has no source documentation. A team would use reverse engineering tools to analyze the code base and automatically generate UML diagrams and database schemas. This provides the blueprint needed for the future maintenance. I hope you understand now. Then, about security analysis. Cybersecurity experts frequently decompile malicious Android apps to understand how they work, how they steal data, and how they communicate with servers. In essence, reverse engineering provides the necessary blueprint of a system, which is the first and most crucial step for maintainers to safely and effectively implement changes. We'll move on to the next slide.